Next video is going to cover objectives 78 through 79. Simplify division and variable bases. So this is going to be the flip of the one that was just played, or the section just before this. So a lot of the things you're going to hear are going to be the same as what you saw in the first video of this part, but it's just now division. So there's a little bit more involved in regards to spreading the problems out and completing it. So we're going to start off with what was talked about in the last video, and that was break into three parts. So again, we're going to look at the signs, simplify them. Odd number of negatives, negative answer, even number of negatives, positive answer. For the numbers this time, now that we're dividing, so we're going to actually divide it, so we're reducing. So you can think of it as fractions a little bit. Third one is letters. Again, we're looking for like bases. Those are the only ones that we can combine the powers with. In this case, we're going to subtract the powers when we get to it. So our rule for this section: like bases that are being divided with your powers, you will subtract the powers if there are numbers in front of the letters with signs. You divide the numbers and simplify the signs. So it's basically taking this and making it into a couple sentences so it kind of flows a little bit better. So that's kind of what we're going to look at. So the problems will look big and look long, but we're going to break them up into smaller parts. So we're going to again start simple with the problem. We have s cubed divided by s squared. So again, we're going to kind of just use this as a checklist. We're going to check our signs. Well, they're both positive, so our answer is positive. There's no numbers in the problem, meaning there's no numbers in front of the letters that we have to deal with. But we do have powers. We're going to subtract powers that are like bases. So in our case, we do have like bases of s and s. So how we want to think of this is the powers is we're going to take 3 minus our 2, and we're going to subtract, get 1. Now the other way that you can think of this is, and look at it, is we can actually expand it out and we can start canceling out what is on top, what's on bottom. So in the top part we have 3 s's, in the bottom part we have 2 of them. Well, we can take this as s divided by s, which would be 1, s divided by s, which would be 1, and finally would leave us at s for our answer. So in either direction that you want to look at this, this is going to be a little bit more difficult to do once you start getting into larger problems, especially with bigger powers. This is the way that you want to go. So either way, you're going to end up with s for your answers. You may want to write this first, but you'll never see the 1 up there. Again, 1 is going to be an assumed number. It won't be shown up there. So in our example here, if we throw everything at you, we have powers, we have numbers in front of the letters, but we have like bases and they have powers to them. So again, if we take a look at our negative and our positive, we are negative divided by a positive gets us a negative. Our second step, we're going to take and divide the numbers. So 20 divided by 5 gives us 4. Our third step is we're going to look at the powers on the like bases. We're going to take 12 minus 10. That's going to give us a power of 2 with the like base of b. So we just put all this together. So we put our negative, our 4, and our b squared, and we have negative 4b squared for our answer. So it simplifies the process down instead of looking at such a large problem. Again, starting simple, and here comes some of the bigger ones that we're going to look at. So here's our first example of a large problem. 6x cubed, y 6, z squared, plus 8x, y fifth, z. All of that is divided by 2x, y to the fourth. So now there's going to be a lot of things that you're looking at. If you take a look at this problem as a whole, pretty overwhelming. So we want to break it up. And you can do this in algebra. So if we look at the breakup, we're going to split this in 2 different problems. So in our first problem is our first term, 6x cubed, y to the 6th, and z to the squared, over 2x, y to the 4th. We're going to do that for the back end. 8x, y fifth, z. So we're going to put this over that. Separate the problem out. Now you have 2 simple problems like we just did in the last example, instead of looking at the whole problem. Because these could get very long, and you're going to see some of those as you can. So we take our numbers first. Our signs are positive, so we don't have to worry about that. So in our first case of we take 2 into 6, leaves us with 3. So we're, in a sense, reducing a fraction. We're going to look at our like terms. our like bases are x and x, so we have 3 minus, and again you don't see the 1 down there, but it's always there, so you make sure you put it in there. 3 minus 1 is 2. We take our like bases of y, 6 minus y to the 4th, 6 minus 4 is 2. So we're going to put all of this together into our answer. In the second part, we have 2 into 8 leaves us 4. Our x power again is 1, but 1 minus 1 is 0. There's that rule that we talked about earlier in this section. Anything to the 0 power is always 1. So really the x will go away in this problem, or in this part of the problem. We have y5 minus y4. That gives us just y, or y to the 1 if you want to think of it. There are no z's down in the bottom, so the z's stay. So there's nothing that we're going to do with them. They'll just come into the answer. So now we put this all together. We're left with a 3 here. We're left with x squared, y squared, and our z squared just comes with it. Same with the other side. We're left with a 4. We're left with no more x's because x power of 0 went to 1. We're left with 1y and 1z. And that's our answer for that example. So again, break it up, make it into smaller chunks. It's going to help you in the long run. So here's a couple other ones. So we've got this problem, a lot of terms. There's actually 3 terms in this one, divided by 6x. So we're going to break it up into 3 different problems. So we're going to take 6 into 12, leaves us with 2. We're going to subtract our x's. 2 minus 1 gives us our x. There's no y. 6 into 24 gives us 4. Again, 2 minus 1 for your powers of x. 6 into 12 leaves us with 2. There again, our x's go away. They can cancel. There's no y at the bottom, so the y comes in. So our answer ends up as 2xy to the 4th plus 4xy plus 2y. So again, a lot of things going on in the problem. Break it up. Make it simple for yourself. Our last example on this one, 12xy to the 5th, 12xy to the 4th, 3x squared, y squared, and it's all divided by 3xy. So again, break it into 3 parts. Here, here, and here. So again, we're canceling the 3 into the 12, leaves us with 4. Our x's cancel out. We have y to the 4th, 5 minus 1. In our second part, 3 into 12 again leaves us with 4. Our x's go away. Y to the 4th minus y to the 1 leaves us with y cubed. Our last part, our 3's go to 1. So we, again, do not have to put the 1 there. We do have an x squared over x. 2 minus 1 leaves us with x. 2 minus 1 leaves us with 1y. So our answer for this is 4y to the 4th plus 4y to the cubed plus xy. You're not going to see the 1 in front of that number. So as you go through this, you want to break them up. Piece them together until you get good at these. Once you get good at these actually go pretty good and are pretty fast in the solving process of these. And that's what we're going to do on the last one, is we're not going to break it up. So we're just going to take the 4 into the 8, the 4 into the 16, and the 4 into the 4. So again, we're left with 2 here, 8 here, and 1 here. Again, you won't see the 1 in your answer. We would take 3 minus 1. 2 minus 1 gives us x squared y. So there's our 2, x squared, and our y left over. In the middle part, we have our 8. 2 minus 1 leaves us with 1x. Our y's cancel. And in the back part, we get rid of our 4's. And we also get rid of our x and our y, because 1 minus 1 is 0. Anything to the 0 power is just 1. So our final answer for this one is 2x squared y plus 8x plus 1. So no breakup on this one. We worked with the powers just kind of in our head. We subtracted the like bases. Remember, like bases divide, you subtract your powers. In the other video, it was the opposite direction. So this will take care of this little section here for the fractions.